Hello there, Mr. Sutton here, bringing you the IM374 Extra Practice Number 4 solutions on applications of right triangle trigonometry. This one's got a puzzle that goes with it, so let's take a look at that. So for this puzzle, we're trying to solve the riddle of why did the professional dog walker go out of business? And to solve this, we have to solve all of these trig equations along with these triangles, finding missing sides, all of this to one decimal place. And whatever answer we get, we have to find it in one of these boxes down below, and then whatever box that is, we'll cross it off. Once we've crossed off every box there is for all the 15 problems, the remaining letters should spell out some kind of word or phrase that solves the puzzle. So let's give this one a go. All right, here we go with the first problem. For this one, we just have to solve this equation that they've already set up for us. To get x by itself, I have to get rid of this division by 8, so multiply by 8 on both sides. That gives me x equals 8 sine of 27 degrees. And now I have to go to the calculator to actually see what that is in terms of decimals. So here on the calculator, let me do 8, and then here's the sine button. Here's where sine, cosine, and tangent all live. And then 27, close parentheses. Now actually, before I punch this in, let me double check. You always want to check to make sure your calculator is in degrees mode if you're doing this degrees stuff. So let me go to mode. And I noticed that here I'm actually in radians mode. So let me click down there and then go over to degree and press enter for that. So now it'll actually give me the correct answers when I punch in the correct numbers. So that all comes out to 3.63. So let me put that in there. 3.63, that's this BE right here. Let me cross that off, and it's on to the next problem. For this next one, we're trying to solve this equation here. I'll solve this one by multiplying both sides by 75. So we have 75 tan of 18. And then let me go to the calculator to plug that in. So 75 tan of 18, that's going to come out to about 24.37. So we've got 24.37 down here. Let's see if we can find that. I see that, let's see here, right there, 24.37. There we go. So now on to the next. For number 3, we've got sine of 40 degrees equals 4 over a. This one's going to take a couple steps here in order to solve for a. So first, I would have to multiply both sides by a to get a out of the denominator. So that would give me a times the sine of 40. And then I would immediately divide by sine of 40 to get the a all by itself on the left. So we end up with 4 over sine of 40, but that's because I multiplied to get a over here and then divided by sine of 40 to get it back here. In any case, let's go to the calculator and see what this comes out to. So we're going to do 4 divided by sine of 40, and that's coming out to about 6.22. 6.22 is right around here. That's this ME. We're crossing that off. Now we've got cosine of 5 equals 92 over y. And we're going to use the same trick we used on number 3, where we have a variable in the denominator. We've seen that we can multiply that over to the other side and then divide by the cosine. So basically, these two things you're going to be swapping whenever you have this situation with a variable in the bottom of the fraction. So we end up with y equals 92 over cosine of 5. And let me go to the calculator for that. So 92 over cosine of 5 is going to give me about 92.35. 92.35 is right here. That's up. So up is out. For the next several problems, they're giving us a triangle with a missing side that we have to find to one decimal. So let's go ahead and try this one out. All of these are going to be right triangles. So my strategy on all of these, I'm immediately going to write SOHCAHTOA out, just so I can remember all 3 of my trig ratios. Then I'm going to figure out which one I'm using based off of the side that they've given me and the side that they're looking for. That'll help me set up an equation that I can then use to solve for x. So right here, based off of this angle of 35, we have the opposite side across from the angle. We also have the hypotenuse. Opposite hypotenuse is so. That's going to be sine of theta equals opposite over hypotenuse. And then for the theta here, we're doing sine of 35. Opposite side is going to be x, and then hypotenuse is going to be 12. Now we have to solve this equation for x, which we can do by just multiplying both sides by 12. So that's x equals 12 times the sine of 35. Let me go to the calculator now and see what that is. So plugging this in on my calculator, I end up with about 6.9 if I round it to one decimal. So that's going to be 6.9 inches based off the units in the problem. I'm not sure what those units really matter here, but we will use them. That'll help us pick one of the answers, which is down here, 6.9. That goes with GH. For this next triangle, it looks like they've given me the hypotenuse and the adjacent side, the side that's part of the angle but not the hypotenuse. So using SOHCAHTOA, adjacent hypotenuse, that's ka for cosine, equals adjacent over hypotenuse. So in this case, we've got the cosine of 54. Adjacent side was this x right here. Hypotenuse was 30. So multiplying both sides by 30 to get x alone, we have 30 cosine of 54. And then let's go to the calculator. So there we go. This is coming out to 17.6. So 17.6 meters using our units here. That's right here. AT is getting crossed off. For this triangle, they have given me the side that's across or opposite from my 22-degree angle. Also, they gave me 85, which is the adjacent side. So for opposite and adjacent, that's TOA. Tangent equals opposite over adjacent. So we have tan of 22 equals opposite side of x over adjacent side of 85. Getting x by itself, we multiply both sides by 85. So 85 times the tan of 22. Let's look at the calculator for that. 85 tan of 22 on the calculator is giving me 34.3 if I round that off. That's in feet. So 34.3 feet. Scanning down here for that, I see that right here, FA getting crossed off. For this triangle, based off of this angle up here, I've got the side that's across or opposite from it, and then I also have the hypotenuse. Opposite hypotenuse, that's the SO in SOHCAHTOA, so sine equals opposite over hypotenuse. So we have sine of 16 equals opposite side x over hypotenuse 14. Multiplying by 14 to get x by itself, I have 14 times the sine of 16. Let me see what that is on the calculator. So 14 sine of 16 coming out to 3.9 if I round that off. So 3.9, and that'll be centimeters for this one. 3.9 centimeters, that's going to be right here, CH, going bye-bye. Next triangle, we've got a 65-degree angle here, and the side that's opposite and adjacent to it. So opposite adjacent, that's the TOA from SOHCAHTOA. So tangent equals opposite over adjacent. So we then have tan of our angle, 65, equals opposite side x divided by adjacent side 9. Getting x by itself, we have 9 times tan of 65. And then let's go to the calculator for this one. So on the calculator, that's going to come out to roughly 19.3. So 19.3 miles for this one. 19.3 miles, I see that right here in the very beginning. That's going to be so cross that off, and it's on to the next. On this triangle, we have the hypotenuse for sure, across from that right angle, and this x side is part of the angle but not the hypotenuse, so it's the adjacent side. Adjacent hypotenuse, that's going to be ka from SOHCAHTOA, so cosine equals adjacent over hypotenuse. So I have cosine of 51 equals adjacent side x divided by hypotenuse 70. Multiplying by 70 to get x by itself, so 70 times cosine of 51. Let's see what that is now on the calculator. 70 times the cosine of 51, calculator says that is about 44.1. We'll take the word for it. So 44.1 feet, because this was in feet. That's right here, RE, crossing that off, and we're on to the next one. For this triangle now, we've got the hypotenuse for sure, And also this angle across, or this side across from the angle 36, that's going to be the opposite side. So in SOHCAHTOA we have opposite hypotenuse, that's sine equals opposite over hypotenuse then. So sine of 36, opposite side is 15, and then the x is the hypotenuse. So this is our first triangle being given to us sort of problem where x ended up in the denominator. But remember, when we have this situation, we can basically swap the x and the expression over on the left side here. So this is going to be x equals 15 divided by sine of 36, which I can now look up on my calculator. So plug in all that in, 15 divided by sine of 36, that is 25.5, and that one's going to be in meters for this one. So 25.5 meters, that's CA right here getting crossed off. And now we come to the last of the problems where it's just a plain old triangle with an X on it. This time around they gave us a side that's opposite from our angle, and they also gave us this adjacent side. They didn't give us the hypotenuse, that one's blank there. So we have opposite, adjacent, TOA. So tangent equals opposite over adjacent. So that's going to be tan of our angle, 60. Opposite side was this 100 over here, divided by the adjacent side, x. And just like we've been doing, x in the denominator, we're going to swap this with the expression over on the left side. So we have x equals 100 divided by tan of 60. Now for the calculator. So plugging that in, we end up with 57.7 on there. And that's going to be in inches. 57.7 inches I see right here. This is an RE. I feel like we just crossed off RE, but that was a different RE. So RE is not very popular on this one. Sorry, RE. And now we're on to do a couple word problems, kind of, sort of. For number 13, we've got this ladder problem. We have a 25-foot ladder leaned against a wall with a 72-degree angle with the ground. We want to know how high up the wall reaches, or the ladder reaches on the wall. So we're looking for x. I mean, we could have just been given the triangle without all this wordage, and the picture would have made it pretty clear what we were doing, but that's okay. So let's figure this out. So the side that we're looking for, x, is opposite the angle they gave us. They also gave us the hypotenuse. So we are looking for opposite hypotenuse, sine. We have sine equals opposite over hypotenuse. So sine equals 72, or sine of 72, I should say, equals our opposite side, x, divided by the hypotenuse, 25. X then equals 25 times the sine of 72. Now I need the calculator. So 25 sine of 72 on the calculator, that's coming out to 23.8 if I round that off. And that's going to be in feet for this one. So 23.8, that's how high up our ladder is going to go on the wall. And just as a sanity check, the ladder should be longer than the distance on the wall, which it is. So now let me see if I can find that down below. 23.8 feet is right here with OP, so cross that off. For this one, we have a ship sailing toward a small island 800 feet away. So our ship presumably is over here on the left. Here's the island over here on the right. And the ship is, oh no, 2 degrees off course. By how many miles will it miss the island? Well, I mean, you're thinking 2 degrees. It can't be that far off course. But let's find out. So we have SOHCAHTOA is kind of our go-to on this because we've got a right triangle again. And we have the opposite side here. And this 800 is the adjacent side now. It's not the hypotenuse. So we have opposite over adjacent, tangent. So we have tangent of 2, which is the smallest angle we've dealt with thus far. Opposite side was x. Adjacent side was 800. To get x by itself, we multiply both sides by 800. So we have 800 times the tan of 2. Let's use the calculator to figure out this. Here we go, 800 tan of 2. And that is about 27.9. So this is 27.9 miles, which is actually pretty far off course for such a small degrees, but it's over the course of 800 miles, so I guess it adds up. Anyway, let's find that in our boxes down here. I see that right here. Ow! Let's cross that off. Now we have our last problem here, the final boss battle, I guess. It's kind of the same difficulty level as the others. This time we have a cable from the top of a 200-foot telephone tower making a 50-degree angle with the ground. And you've probably seen these before if you've done any kind of mountain hiking. You see these at the top of the mountain. Anyway, we want to know how long this cable is going to be. So we've got the hypotenuse. We have the opposite side. So with SOHCAHTOA, we again are using the sine, equals opposite over hypotenuse. That's going to be sine of 50 equals opposite side 200 over hypotenuse of x. To get x by itself, we're going to use our little trick of swapping the denominator down here with the number over here on the left. So we have x equals 200 divided by sine of 50. And now I need the calculator for the final answer on this. So 200 divided by sine of 50, that comes out to 261.1, and that was going to be in feet. 261.1 feet is this VE, so let's cross that off. At this point, we've crossed off everything we could. It's time to look at the letters that remain and see what it spells out. So we've got an HE, I believe that's he, because after that we have LO, so I don't think that's one word, so we just he. And then LO by itself, probably not a word, but this ST suggests that we have a lost is our next word. And then down here we have an HI followed by an SL. I'm thinking HIS is going to be his. And then this L is part of our next word. We have L, E, A, still not a word. The last two letters, SH. So that would spell out leash. So why did the professional dog walker go out of business? He lost his leash. Maybe like he lost his lease? I don't know. Anyway, till next time, Mr. Sutton signing off.